Okay, so today we talk about that pole 0, the concept of pole 0 in Z transform. So, we have already covered that what is Z transform and what is its properties of the Z transform we have covered, and we have already said that Z transform used to define the systems. So, pole 0 concept of the system. So, today's lecture I will talk about that what is the pole 0 concept in Z transform, what is its significance, how do you locate the pole 0 in Z plane, all those things we will cover. So, let us talk about that xz. Xz is a rational function which is a ratio of bz by az. Let us say bz is b0 plus b1 z to the power minus 1 bm z to the power minus m, which can be written as k equal to 0 to m bk z to the power minus k. Bk is the coefficient and zk is the z domain transfer function. So, xz is the z domain transfer function. Now, if you see how many solution of z is available in this equation. So, this is the mth order equation. So, I can get m number of solution of this equation. So, those m number of solution is the, so z equal to, I can get that m number of z value for which this equation becomes 0. So, that is the solution. Okay. So, those solution, each of the solution is called the position of the 0. Why it is 0? Why this solution of this z is called 0 and solution of this z is called pole? What is the concept of pole and 0? Let us say I have a transfer function hz, which is a function of let us say bz by, which is given bz by az. Now, I know the m number, for m number of those z value, the bz will become 0, then what will be the value of hz? Hz will become 0. So, that is why the solution of bz is called 0. So, since in the mth order equation there is a m number of solution of z is available, that is why I call bz has an m number of 0. So, the solution of bz is called 0 position of the transfer function. What is pole? So, generally physical concept of 0 means for those value, the value of the transfer function become 0. Now, what is the pole? Pole means the value of az for the value of z for which az becomes 0. Once you say that az becomes 0, then I can say 1 hz. What is the value of hz? Hz will be infinite. So, that is why at the pole the system will resonate. That is why it is the infinite, the amplitude is infinite. So, solution of az is called pole. So, if I say the z plane, so you can say the solution of this z. So, if this is my z plane, then the solution of bz will be located somewhere in here. Those are called 0. The solution of az also located in somewhere in the z plane, those are called pole. So, this is the concept of pole and 0. Why it is 0? Because for those z value the hz becomes 0. Why it is pole? For those z value hz becomes infinite. So, that is the pole 0 concept of z domain transfer function. Now, if you see this is z to the power minus 1, if I want to make it positive, so z to the power m. So, if I take that b0 z to the power m is outside of this equation, then I can say b0 is 1, so z to the power m, b1 by b0 into z to the power m minus 1 plus dot 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 bm by b0. And similarly, if I want to express in plus in z domain, I can take that a0 z outside, then I can get z to the power n plus this one. Now, if I want to say that this is the mth order mth order equation, so I can say the m number of solution is possible, z minus 1, z minus 2, z to the power m, for which this value becomes 0. So, those z value, this z1, zm are called 0 position of the 0. So, if I want to plot those value in z plane, let us say I just take a slides and I will show you that suppose this is my entire z plane, this is my entire z plane. So, this is my entire z plane. So, z minus 1 into z minus 2 dot 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 z 2 dot 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 z minus z m, those are those for those z value, that upper portion becomes 0, transfer function becomes 0, that is why those are called 0. Let us locate those 0 by a cross. So, let us say z 1 is here, so this is a 0, let us say z 2 is here, so this is a 0, let us say z 3 is here, maybe negative, I do not know. So, those are the 0 position of the transfer function in the entire z plane. Similarly, if I said this one z minus p1, z minus p2, so for p1 this functions becomes 0. So, I can show those p1, p2, pn are the pole of the transfer function. So, I can say those, let us say pole is represented by a circle. So, this is p1, this is p2, let us this is p3. So, all those are pole in the z plane. So, I can analyze the transfer function and I can determine the pole position of the transfer function in the entire z plane. Then what will happen in here? Z to the power minus m divided by z to the power minus n. So, if it is goes up, then z to the power m plus n. So, I can say that n number of pole are in origin, because z equal to 0 is the solution. So, n number of pole at origin and m number of 0 at origin, m number of 0 at origin. So, I can say m number of 0. So, when I go to the plot, I can say in origin there is a n number of pole and m number of 0. So, any transfer function, I can say it is a combination of Hz is a combination of pole and 0, pole and 0. So, what is the meaning of 0? 0 means those value for which Hz becomes 0. Pole means those value, for those z value Hz becomes infinite. So, those are called pole and 0 of a transfer function. This is called pole 0 concept. Let us talk about that our interest, that why we go for the Z transform in digital signal processing, because Z transform is a well known in mathematical subject, but how do we use in Z transform in DSP, digital signal processing? So, our interest is the LTI system. Okay, forget about the slide, what is written, just listen it. So, LTI system, linear time invariant system. Let us say I have an LTI system whose impulse response is Hn. Hn is the impulse response of the LTI systems and Xn is my input. So, I know if I have a system which is H of n, if I apply a input of x of n, I get y of n, which is nothing but a convolution of h of n convolved with x of n. Okay. Now, instead of direct convolution in time domain, what can I do in z domain? Suppose I want to find out the transfer function of Hn in z domain. So, what I should do? I should simply take the z transform of Hn, I get the Hz. I simply take the z transform of Xn, I get Xz. Okay. Now, if I get the Xz and Hz, I can get the Yz just multiplying the Hz and Xz. Then suppose I want to get the Yn, I take the inverse z transform of Yz, I will get Yn. Now, suppose I know the output signal, I know the input signal, I want to derive the transfer function. So, if I know the Yz, if I know the Xz, the transfer function is nothing but a yz by xz. Let us say I have an LTI system which can be expressed in a constant coefficient differential equation. I have an LTI system which can be expressed using a constant coefficient differential equation. So, this is the constant coefficient differential equation, yn is equal to minus k equal to minus 1 to n a k y n minus k and k equal to 0 to m b k x n minus k. Now, if I take the Z transform of this, if I take the Z transform of this will be not n, this will be k. So, I take the Z transform, so I know, so this will be capital YZ, this will be capital XZ. So, I can say YZ, if I take the Z transform, it is YZ Z to the power minus k, this is XZ Z to the power minus k. So, I can say YZ is equal to YZ plus k equal to minus infinity or k equal to let us say 1, instead of minus infinity let us say 1, it is 1, because there is a 1 minus 1. So, this is minus 1 and this is 0, sorry there is a mistake, this is minus 1 and this is 0. So, k equal to minus 1, k equal to minus 1 to n, I can say a k y z z to the power minus k is equal to, I can say k equal to 0 to m b k x to the x z z to the power minus k. Okay. Now, if I say that what is y z? So, y z is nothing but a into 1 plus k equal to minus 1, sorry k equal to 1 not minus 1, 1, k equal to 1 to n a k y z to the power minus k. So, this side will be there is equal to, I can say x z is outside, k equal to 0 to m b k z to the power minus k. Now, if I want to calculate y z by x z, so this will be in top and this side will be goes in down. So, I can say h z which is nothing but a y z by x z is nothing but a k equal to 0 to m b k z to the power minus k divided by 1 plus k equal to 1 to n a k z to the power minus k. So, this is my transfer function of h z. Okay. So, this is my transfer function. Now, how many zeros are there? M number of zeros are there. How many poles are there? N number of poles are there. Now, suppose I said that m number of zeros are there and n number of poles are there. So, I can say the h z is equal to summation of k equal to 0 to m a k z to the power minus k divided by 1 plus k equal to 1 to n b k z to the power minus k. Okay. So, there is a m number of zeros and n number of poles. Now, I said if a k equal to 0 for k equal to 1 to n, that means this part is equal to 0. The coefficient a k is equal to 0. So, if this is 0, sorry, a k equal to 0, this will be x, sorry, this will be a k, this will be b k. b k with x and a k with y. So, this will be a k. So, if it is, I can say that, sorry. So, a k is equal to 0. So, a k equal to 0 means not this one 0, this one is equal to 0. So, if this is equal to 0, then I have only the upper portion, z k equal to 1 not 0, k equal to I can say 1 or 0, k equal to 1 to m b k z to the power minus k. Now, if I want to say make it positive, this one is positive instead of minus k. So, if I take z to the power 1 by z to the power minus m, it becomes z to the power m minus k. So, if you see this Hz is only contained m number of 0 and m number of pole at origin, and m number of 0 in entire z plane. Then this is called all zero system. Similarly, if I say Bk is equal to 0, then the upper portion becomes 0. Then I can get B0 divided by 1 plus this one, and so B0 is, again I make it positive. So, B0 to the power z to the power n divided by this one. So, this has n number of pole and n number of 0 at origin, and m number of pole in z plane. So, that is called all pole system. So, when I want to implement an LTI system, when we discuss about that implementation of LTI system, either it will be all pole system or all zero system. When it is all zero system, I can say if m is finite, then it is nothing but a FIR system. If m is finite, it is nothing but a FIR system. When I talk about the all pole system, it is called IIR system, infinite impulse response system. Okay. So, all pole system, all zero system. So, Z transform is used to determine the transfer function of LTI system Hz, and then I can find out the pole zero system. I can convert to all pole system or all zero system using that Z transform manipulation. Let us, for an example, in application side, let us say human vocal tract. Human vocal tract can be derived, the mathematical expression of the human vocal tract can be considered as a all pole system, which is G by Az. G is the gain and Az is equal to this one, where Az is equal to 1 plus k. So, there is a n number of pole present in the human vocal tract. I want to give an example. So, let us say Vz is a real function and is a real roots of Az. So, Vz has a real roots of Az. If it is real root, n number of poles are there and is the real, then I can say that all poles occur, n number of poles are there. So, if it has to be real pole, then if it is even if complex, that occur in a complex conjugate. So, I can say that there is a n by 2 number of complex conjugate pair of the pole. What do you mean by complex conjugate pair? Now, suppose if I have a plus jb in my one pole, then if it is complex conjugate, that will be a minus jb. Then only multiplication becomes real. So, I can say that Az is a real. Az is not an imaginary function, it is a real function. So, all roots of Az are real roots. Then I can say the Az consists of n by 2 number of complex conjugate poles. So, if I want to say that, how do I represent a plus jb and a plus minus jb in a complex plane? This is the real axis, this is the imaginary axis. So, this is a plus jb, theta is positive. When I say a plus a minus jb, the amplitude is same, but only theta is negative. So, that is why I can say in a z plane, if it is inside the unit circle, so this is unit circle, then will be a1 and there will be a a1. So, those two are complex conjugate pair. There will be a a2, there will be a a2, there will be a a3, there will be a a3. Only the theta is negative, but the amplitude of the poles are same. because any pole is a complex, so AK can be represented RK plus e to the power j theta k. A plus JB can be represented R and theta, which is nothing but R e to the power j theta. So, if it is A plus JB, then R e to the power j theta. If it is A minus JB, it is R e to the power minus j theta. Now, what is the significance? What is the significance? So, how do you relate pole 0 in physical system? Already all of you have already known the Laplace transform Bode plot. What is a Bode plot? Bode plot is nothing but a x-axis is the frequency, y-axis is the intensity. So, it is nothing but a frequency response of the system. Similarly, here also from the pole position, the pole which is close to unit circle basically give you a resonance frequency. So, each pole corresponding to the resonance frequency in speech application which is called formant. So, if I say theta 1 and theta and minus theta both has the same frequency, e to the power j theta related to the frequency. So, same frequency and the formant has a bandwidth if it is not in unit circle in the origin. So, each pole corresponding to a formant frequency which is called resonance frequency of the system. Let us say I have an n number of poles. So, I can plot it. Let us say this is the RK, let us say the two poles are there, VKZ is equal to 1 minus AK z to the power minus k complex conjugate pole. Those are the complex conjugate. So, if it is complex conjugate, I can written down in term of theta. So, theta is related to the resonance frequency and the RK is related to the bandwidth of the resonance frequency. In application, theta is related to the resonance frequency and RK is related to the bandwidth of the resonance frequency. So, let us say system, let us say I have observed a speech signal, I found it has an 3 formant F1, F2, F3. F1, F2 and F3. There is a 3 formant in the speech. This is the frequency transform of the speech signal. So, this is the output frequency representation. So, I want that what should be the transfer, how many poles are there in the system, in the VZ. So, what I said, one complex conjugate pair is related to one formant. So, theta 1 related to one formant F1, theta 2 will be related to F2 and theta 3 will be related to the F3. So, if I say how many complex poles are there? 3 into 2. How many complex conjugate pairs are there? 3 pairs. Now, suppose I measure the frequency of this formant frequency, resonant frequency. So, this is around 500 hertz. So, how this is related to the theta? So, I give a complete example. Let us say I will take in slides, I give you the problem and then I solve it. Let us say I said the problem is look like this. Let us say that I have a speech signal, I have a speech signal and signal, time into speech signal is nothing but let us say SN. SN is the speech signal, which has a sampling frequency is Fs. Fs is equal to 10 kilohertz. Okay. So, I have a digital signal, it may be a speech, let us say speech, and it has a sampling frequency 10 kilohertz. Now, after analyzing the signal, I found SN has a formant frequency F1 is related to 480 hertz and first formant has a bandwidth, this bandwidth is equal to 100 hertz. Then I have an F2 which is related to let us say 50 hertz and bandwidth is equal to let us say 60 hertz. And I have an F3 which is related to let us say 2250 hertz and bandwidth is equal to, let us say, 50 hertz. Can I derive the transfer function of that vocal cords during the production of SN? How do I derive the transfer function of the vocal cords during the production of SN? That is my problem. So, how do I solve it? Very easy. So, what I said, the theta is related to the formant frequency and R is related to the bandwidth. So, as you know the discrete, then in the first class I have said the normalized discrete frequency, if the sampling frequency is equal to 10 kilohertz, then I know that maximum rate of oscillation is 2 pi. So, 2 pi is corresponding to 10 kilohertz, or other hand I can say 10 kilohertz is corresponding to 2 pi radian. Then 1 hertz corresponding to 2 pi by 10 kilohertz radian, or nothing but an Fs. Then I have a theta. I have to find out the theta for a 480 hertz. So, I can say that theta 1 is equal to 480 hertz multiplied by 2 pi by 10 kilohertz, 10 into 10 to the power I can say 3 radian. If I want to multiply, want to get an angle, so I can say pi is equal to 180 degree, I get the value of the theta. Or reverse way, if I know theta, I can calculate the formant frequency. So, if I know the Z representation of the SN or vocal tract, I can find out what is the formant frequency related to the pole number 1, pole number 2, pole number 3. Vice versa. Then what is bandwidth? What is the bandwidth is related to the R? So, bandwidth is related to R is nothing but that Bk is Rk is e to the power minus Bk, where Bk is the bandwidth in radian, or I can say Bk is equal to minus ln of Rk. So, if I know Bk in radian, then I can calculate R. So, what is given? Bk is given in hertz. I have to convert it into the radian. Once I know the radian in Bk, I can calculate Rk also. Vice versa. If I know Rk, then I calculate that transfer function also. Once I know theta k and Rk, I can find out the transfer function is Z domain or the vocal tract. So, Z domain representation can give me that what is the frequency response of the system analyzing pole and 0. So, that is why it is required pole 0 concept. As I discussed in stability in the first class of Z transform, that if the poles are at unit circle, that means it will be a self oscillatory system. If the poles are within unit circle, that means the oscillation will be die down or decay down. If the poles are outside the unit circle, that means oscillation is gradually going up. So, based on that I can find out the stability of from the Z transform I can find out the stability of the system also. So, if the system wants to be stable, the all pole must be on the inside the unit circle. Unit circle means Rk is equal to 1. Okay. Now, if you see, then if I say that I have a pole position like this, then which resonance frequency will be prominent? The prominent resonance frequency means when the Rk value tends to 1. Because it is constant, oscillation will be there unless it will be die down. So, if the Rk value tends to 0, then oscillation will initially die down. So, when I say the poles are at 0 position, Z equal to 0 is a pole, what is the contribution of this? The contribution if this is that when the poles are at 0's position, oscillation is there, but RK value is equal to 0. So, if the RK value is equal to 0 means bandwidth is equal to 0. So, I get an infinite power at a particular frequency, at resonance frequency, but when is RK value is not 0, I get an bandwidth of the formant or resonance. Okay. So, this is the concept of pole and 0, and that is why I have to do the Z transform. I have a given example, I think not this one. Let us say one example might be like this. Let us say I taken another slide. So, suppose if I told you derive the transfer function of an LTI system which is expressed in a differential equation y of n is equal to, let us say 0.5 minus 0.5 y n minus 2 plus, let us say 2 into y n minus 1 plus, let us say 5 into x of n plus 3 into x of n minus 1. This is my differential equation representation of the y n. Derive the transfer function of this system, the system which is produce y n, find out H z. So, if I want to find out H z is nothing but a y z by x z. How do I do that? I take the Z transform. So, y z is equal to minus 0.5 into y z, sorry y z, z to the power minus 2 plus 2 into y z, z to the power first bracket z to the power minus 1. Then I can say plus 5 into x z, because no delay. So, z to the power 0 means once, plus 3 into x z into z to the power minus 1 plus, okay, done. Now, I put the y this side. So, y z plus 0.5 y z into z to the power minus 2 minus 2 y z into z to the power minus 1 is equal to 5 x z plus 3 x z into z to the power minus 1. Now, I take y z. So, that is nothing but a 1 plus 0.5 z to the power minus 2 plus minus 2 z to the power minus 1 is equal to x z 5 plus 3 z to the power minus 1. Now, if I say y z by x z is equal to 5 plus 3 to the power z to the power minus 1 divided by 1 plus 0.5 z to the power minus 2 minus 2 into z to the power minus 1. Okay. So, this is the transfer function H z. Now, if I say how many poles are there? 2. How many zeros are there? 1. I can make it positive also. So, if I want to make it positive, so z to the if I multiply by z to the power 2 both side, upper and lower both. So, I can say z to the z square, multiply by z square both. So, 5 z square plus 3 z divided by z square plus 0.5 minus 2 z to the power 1 z. I can make it positive z. Okay. So, this is the z transform representation of the transfer function. Okay. Now, some problem which is related to the Z transform I will discuss, and then I end this class, because this class is related to the. So, I have already covered the Z transform. So, that is why some problem I will discuss. Let us say given in sequence x n equal to u n, you know what is u n? U n is a unit step function, that means at n greater than equal to 0, that all are 1. So, this is u n. Now, if I want to take the Z transform of x n, x z, I know this is n equal to 0 to infinity, because this side it is 0. So, I not take n equal to minus infinity to infinity, I take n equal to 0 to u n z to the power minus n. So, I can say z to the power minus 1 into n. So, it is a series. If it is series, you know that r square 1 plus r square plus r cube dot 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 r to the power n is equal to 1 by r. So, I can say x z is equal to 1 by 1 minus z to the power minus 1. So, I can say minus 1 means 1 by z. So, z by z minus 1. Then what is the ROC? Region of convergence, for which x z is not infinite. Here is another point. For every pole, x z is infinite. So, that is why the pole are not within the convergence of the Z transforms. Pole are outside of the region, or I can say the poles are not included inside the ROC. Poles are not included inside the ROC. Understand? So, I can find out for which x z is finite, that is the region of convergence, that is this. Okay. So, that way we can solve for another problem. Let us say consider x n is equal to a to the, so there is a constant multiplication, a to the power n u n, same problem, I am multiplying by a constant. So, it is nothing but a, so a will be multiplied. Region of convergence I can calculate. Okay. So, it is a to the 1 minus a. Okay. Similarly, those are the table, you can get the table of Z transform. This is a table for which Z transform is already given. Using that table, when we go for the Z transform, we can use this table, or when we go for the inverse Z transform, we can use this table. Let us say another one, find the Z transform for the x n is equal to, you can do it, 10 sin 0.5 pi n u n. Line number 9, what is line number 9? Sin of a n u n, is this one is the Z transform. So, you just put the value, you can get this Z transform. Or you can do it, z to the power n equal to minus n to infinity, put that value and find out the Z transform. Okay. So, that is the complete Z transform we have covered. Now, we go for the inverse Z transform in the next class. Okay. Thank you.